This is Standard 8 SPA1, where we're going to start looking at statistics and probability. Now, there's a long list of things on this first standard, so let's look at these first. It said from two variable measurement data, in other words, like an X and a Y, they want you to construct and interpret scatter plots, investigate patterns of association between two variables in scatter plots. In other words, we're going to look at the patterns between the X and Y values, describe patterns of clustering in scatter plots, describe outliers. Outliers mean those that lie on the outside of the data, those that don't fit. Identify positive and negative variable association in scatter plots. Is the slope positive? Is the slope negative? Identify linear and nonlinear variable association in scatter plots. Whenever we look at the association, does it look like it's about linear, or does it give us a curve, or does it go up? Is it linear or is it not? So let's start with constructing and interpreting our scatter plot. They've given us some data here. It says, Sophia works part-time in a grocery store. One of her responsibilities is to place oranges into plastic bags and weigh them. She then records the number of oranges and the weight for each bag. One of Sophia's records is shown below. Okay, so this is the number of oranges that she's put in, and this would be the weight. Construct a scatter plot to represent the given data on the coordinate grid below. Okay, so let's make our scatter plot. Our first data point is 3. At 3 oranges, it weighs half a pound. Okay, 3, half a pound. So let's look down here at our X and Y values. Number of oranges, weight of the bag. 3 oranges, it said it was a half a pound. Look, these are in halves, 1/2, 1, 1.5, 2. So at 3 oranges, we've got half a pound. So let's put that point in there. Let's go to the next point. So we got that one. Let's go to the next one. At 3 oranges, when she put in 3 oranges, she got 1 pound on this one. So you got some bigger oranges, right? 3 oranges, 1 pound. That point goes there. Now, at 3 oranges, we got some really big oranges now. She has 2.5 pounds is what it weighs. So at 3 oranges, this one was 2.5 pounds. There are 3 points so far. Then at 4 oranges, we had really small oranges. It only weighed 1 pound. Those are some really small oranges, right? Okay, 4 oranges, 1 pound. Okay. Another one she had 4 oranges, and they weighed together, they all weighed 1.5 pounds. So 4 oranges, 1.5 pounds. See how we're plotting these? 1.5 pounds, because that's your weight. Now let's look at the next one. Then she put in 5 oranges into a bag, and it weighed 3 pounds. So let's plot that one. 5 oranges, let's see, 3 pounds. That would go right here. 5 oranges, 3 pounds. Okay. Then this one, we've got 5 oranges, and it weighed 4 pounds. So let's plot that one. 5 oranges, 4 pounds. All right. Then she put in 5 oranges this next time, and she got 3.5 pounds. So let's plot that one. 5 oranges, 3.5 pounds. Okay. Then she put in 6 oranges, and she got a weight of 3 pounds. So these are small oranges, right? Oranges that don't weigh much. 6 oranges. What was that? 6 oranges, 3 pounds? 6 oranges, 3 pounds. Yes, okay. 6 oranges, 3 pounds. Right there. 6 oranges, 4.5 pounds. 6 oranges, 4.5 pounds. And then 6 oranges, 5 pounds. 6 oranges, 5 pounds. Now we plotted our data. Look, the data tends to go up. As we add more oranges, we tend to have a heavier bag, don't we? What does this tell us about the weight of the bag as she adds more oranges? More oranges generally means, gives us a heavier bag, right? That's the way it's trending. It's going up as we add more oranges. As the number of oranges increase, the weight of the bag generally increases. Okay, so that allowed us to construct a scatter plot and interpret some of the data there. Let's look at the next one. On this one, we're going to investigate patterns of association between two quantities and the scatter plots. In other words, is there an association? Well, let's look at this. This says, are there patterns of association between the variables and each of these scatter plots? If so, describe the patterns. Well, let's look at this one. As the number of hours somebody studied went up, the grades on the test went up, didn't they? So that's a pretty linear. If I wanted to draw a line through here, I could draw a line that sort of fit the data, couldn't I? Let's look and see. If I started here and put a line through it, I could kind of put a line of best fit through there, couldn't I? All right. So this tells me that there is an association. It is linear. It's going up, isn't it? Okay, it seems to fit a line, and it seems to be going up. So that's a positive association. The slope on this is positive. This is a scatter plot of X and Y values, but there doesn't seem to be any sort of association. There's no pattern, no association. How about this? This says the number of hours that you're doing something is higher and then tends to go down as your age increases. This one seems to look like it fits more, not a linear, but more of a something like that, doesn't it? Okay, more of an association like that. There's an association. The data is close to this line that I've drawn here. Okay, so, but it's going down, so it's a negative association. Okay, is it linear? No, that's nonlinear, right? Negative nonlinear association. Okay, so what have we done here? We have decided whether or not there was an association between the two variables, and we even just talked about what kind they were. And we'll talk more about the linear, nonlinear, positive, negative in a minute. C says, from the two variable measurement data, describe patterns of clustering. Clustering means when things cluster together. Think about it. It's almost like friends. You know how friend groups tend to sit together or talk together in the hallways? This might be one cluster. This might be another. Oh, and then there may be another cluster of people standing over here talking. How about that? You know, these are different clusters. Well, data can cluster too. Let's look at the data that we have here. Doesn't it look like this data goes together and this data goes together? This might even be by itself. You could have 3 different clusters of data if you wanted to look at it that way. But we definitely have 2. Let's look at what this is talking about. The size of a house versus its price. 3,000, that's 3,000 square feet. So these are all relatively normal size houses, the size that most people live in, under 3,000 square feet. These are big houses, you know, almost 4,000 square feet up to 5,000, 6,000 square feet. These are bigger houses. Okay, so there seems to be a cluster of data here and a cluster of data there. That just means that there are segments that go together. That's what your clusters are. So the term clustering, if they ask you about a cluster, you just see which points seem to be sticking together. Next thing is that from these 2 variable measurement data, we're going to identify outliers in our scatter plots. Outliers. An outlier lies outside the regular data. It doesn't fit on the regular data. Here's one where we're looking at a person's ankle diameter, that's the distance around their ankle, versus their knee diameter. Well, you would think as someone's ankles get bigger that their knees would get bigger, right? very small people might have an ankle to knee diameter that was close to the same. And look, most people do, but I've got 2 points that don't fit. I've got 2 people whose knees are a lot bigger than everybody else's compared to the ankle size. I've got people who may have the same size ankles as other people, but their knees are a lot bigger. These are called outliers. These don't fit on the association line or curve that most everything else is close to. These are called outliers. Okay, so we were able to identify outliers in that scatter plot. Now, from 2 variable measurement data, identify positive or negative variable association. Positive variable association means the trend goes up. This is positive, just like the slope. If this is a slope, that's a positive slope. Negative means that it goes down. The association goes down. This is like a negative slope. Think about it this way. Your X has to go up as your Y goes up. If you're talking about the cost of the number of hamburgers, let's think about it this, okay? Number of hamburgers that you're going to buy versus the price. Wouldn't the price go up as the number of hamburgers you buy go up? Okay. There's lots of possible things on negative associations. If you are trying to lose weight and you run more, okay? And this deals with your weight, and this deals with the time exercising, okay? If you don't change how much you eat, time exercising. As your exercise time goes up, let's see, as your exercise time goes up, your weight would come down, okay? So that would be a negative association. Let's look at these and see what we have. Are these positive or negative or no association? Well, if I put basically a line of best fit, that would be a line that would go through them and come close to fitting the data. I think I could put one kind of, I think I could kind of put one right about in here. That's a positive association, right? It's going up. So we're looking at a positive association. In fact, you could call that a positive linear association because it sort of fits the line. Okay. How about this one? What's this one doing? Isn't this one going down? Okay. So that is a negative linear association because the data kind of fits the line. There's 2 outliers here, aren't there? Just like there were 2 outliers on this one. So this one would be a negative association. Okay? It's actually a negative linear one. Is there any association here? There's none whatsoever. I mean, the data is just scattered around. So we have no association on this one. Now, let's identify linear or nonlinear variable association in our scatter plots. Okay, we want to know if these are linear or nonlinear. Is this linear? Well, this looks more like if I were going to model this, it would fit along a line that was approximately like this. So this is nonlinear. Could I call this positive or negative? No, not really, because it's positive through here, and then it starts being negative through there, right? So this is a nonlinear association. Is there an association of here? No, that just looks like there's points all over the place, doesn't it? No association. It's not positive, it's not negative. S-O-C-A-T-I-O-N. Sorry, guys, my pen doesn't work very well sometimes. How about this one? Well, isn't that a positive association? Doesn't it appear to be going up? So that's a positive association. This one's just all over the place. I would say there's no association. How about this one? This is a negative one, but is it linear or nonlinear? Okay, this is positive linear, right? Because it could fit a line. All right, this one's going down, so it's negative, but it's not linear, is it? It curves kind of right in here. So this is negative non-linear. So we have just decided which ones were linear and which ones were non-linear.